Hi, everyone. Welcome to the part 2 session on prototyped production crafting applications with Azure Cosmos DB. I'm Saranya, Principal Product Lead on the Azure Cosmos DB team. And with me here, I have my colleague. You wanted to introduce yourself?
Hi, I'm Sandeep.
And today we are going to take on and do continuation from the part 1 and look at other interesting tips and tricks, best scenarios with the same sample application. So let's get started and move on. As a quick recap, I wanted to just highlight that watching part 1 is really a prerequisite because you will understand the context, like the app that you see the screenshot on the screen. It's an AI-enabled chat app. You would also understand the architecture on which this app was built and helper tools that Sandeep has created to look and understand the SDK diagnostics for a client app as it talks to Cosmos DB and more. Right? So please do take a look at, pause this video, go back, look at that before you come and continue here. With that scenario, quick recap on the scenario itself. The app kind of works well in dev test scenario, so the prototype works very well. And as they take it to production, they see performance issues, scale issues, load test issues, etc. The issue one we saw in the first part of the video was that the application had performance and latency issues, specifically when they moved, say, from a 10K RU partition to a 100K RU partition. And then we understood concepts and mitigation steps on understanding partitioning, data modeling, looking at metrics, looking at SDK diagnostics, understand client-side diagnostics, maybe improvements such as pagination and more. Right. So without due delay, let's get started to the part 2, the next issue or the scenario, the issue 2 in this case. Let's move on to that. So we're going to shift gears and talk a bit on our SDK performances and application crashing on high volume. So the issue that we wanted to highlight here is a console app was built, which uses multiple simultaneous threads to simulate high volume. So essentially, they're trying to simulate a new tenant migration. So ingesting a lot of chat and tenant data into this app. So they have a console app and they're migrating the data. But as much as they say they have issues on two sides, at one side, the application crashes, leading to the poor end user experience. But also the console app's performance is also very poor. So the ingestion isn't happening at the rate that they want, and the actual live applications is also crashing. So with this, Sandeep, do you want to help us walk through analysis steps and how do we look at this issue and analyze?
Sure. So when we deal with the client app failing or crashing, we are looking at the client side diagnostics. We want to understand what's happening on the client side and figuring out what happens on that. Again, you can look at the metrics for any server side errors, but typically the app never crashes because of a server side error. It's typically always on the server client side. So again, we will look at the diagnostics and let's see if the diagnostics gives us some idea on what's going on. In this case, I have the SDK diagnostics for the app already available. So I looked at the app SDK diagnostics, and if you what I saw was that if you look at line number 14 here, the number of clients created is 30, and that is something that is an anti-pattern. So just to explain what's happening here is Cosmos DB client should always be a singleton application, which basically means you should hardly have one instance of it running. And if you have more than one instance, it's not going to be helpful. The reason why we want the SDK to be singleton is because the SDK is a smart SDK. It does all the background communication, and for that it caches a lot of information itself, and it routes all this data to the right partitions or right replicas smartly. Now, if you create more number of clients, then you are eating up more memory, you're eating up more CPU, and you're also wasting a lot of resources because each instance is now caching its own copy, right? So it's not a good practice to have more number of clients. One of the impacts or ill effects of having number of if you want to say of more clients is, if you see here, the transit time, this has gone up because each SDK instance is now holding up a piece of the pipe, and there's a lot of the chaos on the network, and the transit time itself has gone up. So ideally, we would want to only have a single instance of the client. So to check what's happening in the customer's code, I looked at the customer's code, and maybe I should bring that up now and show you what code I saw. So this is the customer's code, and it's a very simple code that way. It's just reading Cosmos DB and then creating multiple threads, and then from each thread, it's trying to generate some requests because this is a load testing app. What was interesting to me is that these three lines are inside the for loop. So if you see, what they're doing is they're generating multiple threads, and each thread has got its own client. Now, this is something people who have been working with SQL, let's say, have been using because you want to see a create connection and close the connection in the same thread, not necessarily reuse the same connection. But here, this is an anti-pattern for Cosmos. If you do this, every thread is going to create a client, and you will see the problem that I showed in the SDK diagnostics. The ideal way to do this is you should not have this code here, but you should have the code here. It's just moving the code a little up. You create the client upfront once, and then pass the same client to all the threads, and no change else required. Everything should just work fine, and you should see a big difference in your performance. Again, this is a simple code on how, because the console app, I could do it this way. If you are building an MVC app or you're building an app in another framework, then please look up how to build a singleton app and use Cosmos DB service as a singleton service in your code. Now, just to demonstrate what would happen once I make this change, let me again go back to the SDK diagnostics that I collected after the code was fixed. And here you can see that the number of clients created becomes 1. And this is what we want. We don't want this number to increase more than 1. It should always be 1. And the transit time issue that we saw earlier would have now reduced. And you can see that the drastic decrease in the time here. So a very simple code change on making sure your SDK is singleton can give you these differences. And this again, I've seen this that you find this typically in production when the load increases, because at slower loads, you don't see the same impact. But as load increases, you start seeing the problems of having a multi-client an environment. So please revisit your code and check if you are using singleton or not. So again, just to show you the problem statement, the code was inside the thread, and because of which you were seeing number of clients is equal to 30. And what we should do is we should have it as 1. But for doing that, we need to move the code up. And once you do that, you should see some improvement in latency. And of course, your application would not crash because you will not be taking up all the CPU and memory that the machine has.
So maybe let's talk a little bit about the concepts here as part of this video, right? When applications crash on high volume, it's important for us to understand some SDK best practices. So we did see that singleton approach is key, and we saw it with a live example out there. It's also important to look, there are some server-side timeouts depending on the Cosmos DB APIs you choose. So it's very important and prudent to look at what timeouts and whether you want to change them and the retry policies. Specifically, I do want to spend some time on SDK error codes and retries. So if we go to the next slide here, we will see that there are specific error codes, retries that have been well documented. specifically for the Java, we have documented that stands good for other SDK versions as well. But understanding error codes and retries are very crucial because they can be different based on whether it's a server-side error or client-side error. What is the error substatus, how those means, based on certain consistency setting versus bounded staleness versus consistent prefix or session, the error codes might also mean differently and might be different. There's also two modes, gateway mode and direct mode. So it's important to understand that differentiation. But last but not the least, very important to understand that error codes can also be transient. As long as the end application performance is not expected in a distributed database scenario, um, it is but natural that there would be some transient errors and self-healing systems that will be when there are partition splits, whenever there are retries and it goes to another region, partition failover. All of these are common scenarios that will happen. Talking of other SDK best practices, moving on. We did talk that there are SDKs specifically for Java, .NET, which are kind of matured, but Python, on which, for example, OpenAI's ChatGPT uses a Python SDK, JavaScript, pretty much maximum number of developer population we have on Cosmos DB use JavaScript SDK, and we've added Go as well into this bucket. Also, another tip here is wherever it's possible for you to do point reads. By point reads, it means key value lookup. That essentially means you do a read operation by providing the ID, which is actually the key. It's the cheapest, more efficient, and the best way of access, as opposed to doing a select or a query. Also wanted to highlight, Sandeep, maybe you want to talk to us about tuning maximum degree of parallelism, max retry, how important these are.
Yeah, so depending on what's your use case, our SDK provides you a lot of fine-tuning mechanisms as settings, and you can play around with it and understand which is best for you. For example, when you talk about maximum number of retries, let's say you are generating a request and it is generating a throttle on the back end. There's contention for resources and you get a 429 error, which is throttling. Now, our SDK by default tries it 9 times. So if you have a throttling, the system will again try to reprocess the request, and only after 9 times will it say that, sorry, I could not process your request. Now, when you say 9 times, it also means that this is sequential. So the response will come to you after all the 9 tries are over. So it can take a little longer. Now, in many cases, the customer really wants to control it. You don't want the SDK to try 9 times. You rather want, you try it once. If you fail, give it to me and let me figure out if I have to try again or not. You want the control on the client app rather than the SDK deciding what has to be done. So you can decide what should be the key, how many retries should the system do when something happens on the platform, like a throttle effect, right? Similarly, how many parallel threads do you want to generate? Because you may not have enough resources to do that. So again, look at the SDK. The SDK comes with a lot of controls in terms of settings. Understand each setting and fine tune it to your requirement. What we have as defaults are the general settings, which we have prepared based on the general use cases. However, your use case may need some tweaking, so spend some time and adjust each of those to your requirement.
Yeah, absolutely. And another, as a caveat, etc. If you do have an extremely read-heavy workload and looking at some millisecond latencies in performance as well, we do have an integrated cache. So version 1 of the cache, you could use that as another example as well. So here's probably all of these things that we wanted to just chat about SDK. Maybe we can go on to the next customer issue as well.
Yeah.
Well, this is an interesting one that we've seen with a lot of customers. This is basically about onboarding new customer tenants. And this is about onboarding new customers using bulk ingestion, right? So here's in continuation to the previous example, so for example, we are trying to migrate customers at scale. As I said in the past, during ingestion, we do notice suboptimal experience on the chat users. It's sometimes available, not available, etc. But also, we have a desktop migration tool, a .NET Console app, and the ingestion speeds aren't great. So double-edged sword as well here.
Yeah, so I can see I'm seeing two issues here. So we'll take it step piece by piece. What we're talking about is throttling on the front end app or the customer facing app, and also not great performance for the ingestion. So we'll take those two items separately, although they are connected. So let's first talk about the throttling problem and see why it's causing it. So again, whenever you see a scenario of throttling or getting errors, the first go-to place is your metrics. Go and look at your metrics and see what's happening. Understanding the problem will tell you what to do. So let's switch to the metrics for this case and see what we can see here. So I have the metrics open for this customer. Here we are saying what are the total requests, and I am splitting it by priority and status code. So what we are seeing is that there's a large amount of throttling happening. There's a 429, which is throttle request. And I also see that the status code is 1, which basically means in this case, all requests that are coming to this collection at this point are all high priority requests. So now, if the application that is also generating more requests, since the system is already throttled, there is resource contention, there is a good chance that your request will also get throttled. Maybe let me just show that to you and show what can be the experience when something like this happens. So here we are connected to the same container that we saw in the metrics, and I will try to generate a request and see if that gets throttled or not. Again, it's a chance. I cannot guarantee that I will always get a throttle because throttling happens sometimes and sometimes doesn't happen. So let's try a few times and see what happens. OK, looks like I got a throttle now. Yeah. So if you saw the status here that I got a 429 too many requests, which basically means my request is getting throttled. So this is a user experience that they're talking about, that sometimes it works, sometimes it doesn't work, and it's not a very rosy picture for the client app. Now, what do we do? Of course, there are two ways to solve this problem. One is increase the RUs. But again, that comes at a cost. You always don't want to change it. You want to deal with it. If there is another way to solve the problem, we would want to do it without changing the RUs, right? So that's where priority of the request comes in. What we can do is we can move to another collection where I have configured the request to be lower priority. So here I've just replicated the same data and same workload once again. But what you see here is that the request that is coming right now from the backend application are all priority 2 requests, which basically means low priority requests. But my app is continuing to send requests at a high priority. So any request that comes from the front end will supersede in terms of priority, and thereby there's a chance that it will not get throttled, right? So again, let's go back to the app, change the let's change this to the LP container, that what is the low priority container that I just talked about, and then show it to you how we do that. OK, while we run the app, what I can also do is maybe show you how to set the priority. Maybe that's an important step. So here in my code, if you see, I can see how to set the, sorry, I have to show it in the other place. So let me show you how to set priority for the request. And here, if you see in the arguments that we have, so I'm taking the, I'm running this application, and if the priority is low, I am setting in the SDK client. When I'm creating my SDK client, I will set the parameters. One second. So here, if you see, and when I say send read data, which is my call, and I will pass the priority, and the priority will be low. So so in the request option, we have an option called priority level, and you can set the priority to be low. So all that you need to do is use your custom logic, figure out which requests are going to be high priority, which requests are going to be low priority, and in your request options, just set the priority level appropriately.
And we have this in all our SDKs, right? We are showing it
yeah.
in .NET, but we do have it in Java, JavaScript, Python.
Yeah. Now we are running the same code. Only thing is the background tasks are running low priority. The foreground tasks continue to be the way it is, and they're running high priority. So now I'm hoping that we don't see any throttling, because we are, this request should supersede the background task, and the application performance should be okay. So by just doing this, we have solved the problem of throttling. Like I said, you could have always used auto scale for RU to so that the RUs automatically adjust. That was one way to solve this problem. Two, you could have increased the RUs. That would have a cost implication. So this is the third tool that we can use to improve the performance. While we talk about how we can, by priority, we can improve the SDK request. We also have something similar on the portal. So if you come to the portal, and go to the Data Explorer settings, you can put some priorities on, or some thresholds on how much RUs you want to burn on the portal, because you don't want the customer, somebody to be running a very expensive query on the portal and the customer workload getting impacted. So to make sure that you are, there is some control on the requests that are being run on a production workload, you can come to the portal, go to the settings, and enable the settings that you have. And that could also be another way to make sure that you don't accidentally consume all the RUs and create a bad experience for your production workload. So now we have discussed one part of the problem, which is to say why was the customer's first customer facing app facing some throttling or issues. Now coming to the next part, which is to say why was the ingestion itself slow, and what should we do. Now so for ingestion, the customer here had created a console app, and they were using the bulk utility to import data. However, for bulk ingestion, that may not be a great fit, because for ingestion and large volume of ingestion, we really want a lot of parallelism, and console apps cannot provide that to you. Or it's difficult to configure console apps to provide. Of course, you can do it, but it's very difficult to control it. A much easier solution is to use Spark. And a simple code like this, maybe 10 lines of code, is all that you need in Spark to do that. And Spark inherently is does jobs very in a parallel nature. And to control the speed, all that you need to do is decide the number of nodes and number of worker nodes that you're going to create, and Spark will automatically distribute the work with all the nodes that are available, and it will parallelize it. So in Spark, it's very easy to parallelize and increase or decrease your speed. One additional thing that Spark provides, and that's interesting here, is what we call the throughput control. So here, if you see, I'm saying that my throughput threshold is 0.6, which equivalents to 60%. What it means is I am telling Spark, do not consume more than 60% of RUs that are available. And that's all you should be using for this job. So 60% of the throughput is available for this job, and 40% will not be consumed here. So there is some amount of control, and you can say that I will not consume all 100% just because I put a lot of resources during the ingestion process. So this is kind of putting some speed limit on your ingestion to make sure your production workload doesn't get impacted again. So net throughput control, priority-based execution, and Spark. These are the three keywords I would want to call out for these two issues that we talked about on how to have a higher rate of ingestion, yet not impacting customer workload, and having a best of both worlds.
Awesome. So maybe we can now just recap what we spoke. So by recap, I mean the analysis steps, Sandeep, that you went through, specifically why parallelization is critical, how throttling can cause performance issues. We should ensure the ingestion doesn't take 100% of our normalized. So either use throughput control using Spark connector or on the client side, or actually have priority based execution. That way, you know which request needs high priority and which request low. You did show to us that auto scale is important and it needs to be configured. Always we say we provide instant auto scale, no warm up, cool down in Cosmos DB. So it's actually a good feature for all of you to use. To top it, we now have dynamic scaling on auto scale. All that means is you will be exactly charged for the exact amount you're using on that exact physical partition or the nodes on which you're using. So it's actually very, very cost efficient. Also check for data skewness. If you're splitting partitions and if the data is completely skewed, then you know all the requests, although there could be RUs lying idle with the other partitions out there, but all the requests will need go to a single partition or a hot partition because the data just exists in that partition. So specifically read heavy workloads to ensure that there is data is not skewed and it's distributed, which means for write-heavy workloads, you choose the right partition methodology such that you don't have data skewness.
You always want to have a team that works together, and you don't want one person to work and rest to be resting.
With the physical partitions, exactly, I agree. So here, quick recap on what Sandeep showed us as well. Quickly on the throttling side and the data skewness side, we see there's no data skewness. However, there was good throttling. So priority-based throttling is important. Moving on from the console app, it's better to use Spark notebooks. And then throughput control and parallelism can be achieved on the Spark notebooks very well. Portal is also a good consumer, can create a lot more throttles more than required. So there's a RU threshold setting on the portal, which was told. And the biggest takeaway of this side is to actually use priority-based execution and choose low priority and high priority tasks. Now, putting in the priority-based throttling, here's a recap of the results. We see the backend jobs are on low priority and high priority are the front-end jobs. So on these snapshots, just a quick give you a quick glance as to say there is no throttling happening in the end users front-end jobs. So always good to use priority-based throttling. So coming close to end of this session, would like to highlight more on concepts around elasticity and throughput optimization. Sandeep, do you want to just quickly take us through these?
So yeah, basically, as we discussed already, so when you talk about distribution of RUs, we want all RUs to be having equal amount, all partitions to be having equal amount of RUs. Use auto scale instead of manual. That gives you the flexibility of having additional RUs in terms of some spike happening. Enable your burst capacity on your collections so that in case there is a spike, we can collect the unused RUs and use it to burst. Hot partition typically becomes a challenge, and that's because of a bad use of a partition key. Again, this is continuing from our session number 1. Change your partition key if you see some hot partition. And priority-based throttling. Use Data Explorer, priority and SDK settings to make sure your priorities are correct.
Yeah, these are really important tips and tricks, especially for those of you who are looking for production. Burst capacity in particular, we accrue the last 5 minutes of unused RUs within a physical partition and you get burst without extra charge. So these are important things that I think people can definitely leverage. So with this, we conclude this video. Do check out the part 3 of this video. We have some more gotchas, best practices, tips and tricks on the same scenario coming up as well. But for now, signing off and thank you from me.
Thank you.